Yahweh, you are a rainbow. This is how you will be greeted if you visit the Republic of Marshall Islands. About 40,000 people live in these atolls, and it is a true paradise in the Pacific. Unfortunately, finding enough fresh water is not easy for them because their one and only source of fresh water is rainwater, and it is not coming enough lately. These islands receive rain from a band of clouds that encircles the planet. It is called the Intertropical Convergence Zone. Let's call it the rain belt. Due to global warming, the amount and timing of rain received by these islands have changed in the past. We are living in a world where data is so much precious to make decisions. We know a lot about our present. What about our past? Our instrumental records only goes back to the mid-20th century, and it is clearly not enough to understand our climate system. So we need to extend these records back in time. But how can we do that? Corals, nature's books of history. Massive corals like this one can grow for several hundreds of years. While secreting their skeleton, it incorporates the chemistry of seawater at the time of its growth, so that each of these elements can act as a fingerprint which can specify a specific marine environmental change. If you take an X-ray of a coral, you can even see growth bands, just like in tree rings. We drill the coral from the top and take a cylindrical core sample. Then I analyze its chemistry from the top to the bottom, which tells me about the history of different ocean parameters such as temperature and salinity. So let's see how we can apply these fundamentals to Marshall Island corals. During the winter, the rain belt lies further south from the Marshall Islands. This brings less rain and increases salinity. During the summer, it comes right above the Marshall Islands, bringing more rain, thus decreasing the salinity. And guess what? Corals can record these seasonal and year-to-year changes in salinity. Based on my results, I could extend the Pacific hydroclimate records back to the mid-18th century. And you can clearly see how the dry and wet conditions have changed in the past. I even expect a drying trend in this part of the Pacific in the future. So my research broadly helps to understand how global warming can impact the freshwater availability in the tropical Pacific. This information is also important to decision makers in implementing management strategies for the future. Reconstructed data from corals can tell us about what and when things have happened in the past and how and why the climate might change in the future, so that we all can fight against climate change now, not tomorrow. Thank you.